Today's lesson is on sinusoidal functions, or the sine function in particular. So this afternoon in this video, we're going to be going through sinusoidal functions. We're going to be graphing a couple, and then I'm going to introduce you to one very specific function called the sine function. After that, you're going to have a little bit of time where you can complete your afternoon assignment and submit that to me. Yesterday we talked about periodic functions. This is a perfect example of a periodic function. We know that this is a function that has a repeating pattern. So here's one period, the pattern starts repeating again, a third time, and then a fourth time. Today we're going to be talking about the difference between a function like this, that is periodic, versus something that is sinusoidal. This is a sinusoidal function. So this is a special type of periodic function. It has a smooth curve, and so it'll be a nice smooth wave. Now, the period of this wave, the amplitude of this wave can all change. So this wave could be stretched out, it could be squished together. All of that is fine. It can still do any of those things and be sinusoidal as long as it's a smooth curve like we see here, where the maxes are all the same and the mins are all the same. Yesterday we learned some new terms. We talked about the maximum, we talked about the minimum, and we talked about the period. Today we're going to learn two new terms here. The first is the sinusoidal axes. So what this really is representing is this line in the middle that is basically like a line of symmetry. So I'm going to highlight the axes here, and on this particular example it is the x-axis. That will not always be the case, and we're going to be going through some examples later on. But for now, this yellow line that I highlighted here is my sinusoidal axes. Oftentimes, if we have a graph, it's very easy to see, but if we don't, and we're just given some information, we could calculate this sinusoidal axis easily by using the following formula. So if we take the maximum plus the minimum and then divide that by 2, we'll get our axes, or our middle line. So if we think about what's happening here, I have a maximum of 2, I have a minimum of -2, and so if I do 2 plus -2, I get 0, divided by 2, and I get 0, which is exactly where this sinusoidal axis is. The second new term that we're going to be talking about is amplitude. So amplitude is how far I have to get from the sinusoidal axis up to the maximum, and it will also be the same if I was going from the axes down to the minimum. So in this case, my middle line is at 0, my maximum is at 2, so that means that my amplitude is 2. And I can double check that if I look at the bottom, and I could say, yes, I go from this middle line here down 2 units to get to my minimum. So the amplitude is, it always has to be the same. In this example, we're going to be drawing a sinusoidal function with an amplitude of 3, a sinusoidal axis of y equals 2, a period of 8, and they want us to show 2 complete cycles. So the first thing that I'm going to do is plot my sinusoidal axes, and I'm just going to write these steps for you so that you have them. So I'm going to draw this dotted line in at y equals 2. So this is my middle point. The next thing that I'm going to look at is the fact that I have an amplitude of 3. So I'm going to use my amplitude to plot my maximum and minimum. So if I have to start at my sinusoidal axis, I'm starting at this 2, and I have to have an amplitude of 3, then I know that my maximum is going to be at the 2 plus 3. So it's going to be at 5. And I'm just going to draw like a dotted line in here so that we can see that. And then I know that my minimum is going to be at the 2 subtract 3. So it's going to go all the way down to -1. Now I have to show 2 complete cycles and they need to have a period of 8. So I know that if I started at the top, 8 seconds later, I need to be at the top again. 8's a little bit hard to see, but it's right here. So this means that halfway through, or at 4 seconds, I need to be at the bottom, so right here, and I'm able to draw in this function. So I'm starting at the top, I need to be able to hit the bottom at 4 seconds, hit the top again at 8 seconds, and then I'm going to repeat this. So I'm going to be hitting this point here, go all the way back down to the very bottom, hit my middle point, and then back up to the very top at 16 seconds, which would be 2 periods of 8 seconds each. I want you to take a minute and I want you to attempt to do this example by yourself. So in this one, we're going to be drawing a sinusoidal function with a maximum of 4, a minimum of -6, and a period of 10. Pause the video now, try it out, and then unpause and I'll do it with you. So I've drawn in the maximum line at 4, the minimum line at -6. This is just a nice visual for me so that I know where my function needs to be in. If this confuses you because you are confusing it with the sinusoidal axes, you don't have to do this step. I just know that it does help some people. We don't know where the sinusoidal axis is here. I know that it needs to be in the middle of this 4 and -6. So remember that formula. I can do my maximum, which was 4, plus my minimum, which is -6, divided by 2. 4 plus -6 is -2, and then -2 divided by 2 is -1. So I actually know that my sinusoidal axis is going to be right in here at -1. I'm basically there. I need to draw this function that has a period of 10. This time, just to change things up a little bit, I'm going to start right on my sinusoidal axis. So I'll put this first point right there. So I know that at 10 seconds, I need to be right at that point again. So this means that at some point, I need to go up, hit back down my sinusoidal axes, and then go all the way down to my minimum just to reach back to 10 seconds for my first period. So I know that at 5 seconds, I need to be in the middle again. So once I do this, it's easy to see that if in 5 seconds I need to complete half, I'm going to be hitting my maximum at 2.5 seconds. So 2.5 seconds, 2.5 seconds more, I'm at 5 seconds. 2.5 seconds more, I'm at my minimum, and then 2.5 seconds more, I'm back at my middle point. And I'm going to continue on this because it does say that I need to do 10 cycles. So I'll put another dot at 15, another dot at 20, and then I'm able to see, hit my maximum, back to the middle, hit my minimum, back to the middle. So far, we've been graphing sinusoidal functions, but we have not actually been graphing the sine function. So the sine function is a very specific function. I'm going to give you a minute right now, and I'm going to get you to fill in this chart. Now, you're going to have to locate your sine button on your calculator again. I do want you to make sure that your calculator is in degree mode, so you need to see the DEG or the D at the top. If not, reset your calculator and change that. And then you need to be plugging in all of these x values that you see for x. So for the first one, you're going to be doing sine of 0, and you should get an answer of 0 on your calculator. So pause the video, take a minute, try and fill this table in, and then unpause it, and I will fill it in for you. So I hope you filled it all in. As you can see here, we do see this repeating pattern. So it's starting at 0, it slowly starts to increase till it hits 1 at 90 degrees. It's starting to decrease again, but the numbers are the exact same. So it's this repeating pattern until it hits 0 again. Now it's doing the opposite. It's seeing the same numbers, but these are now negatives until it hits a minimum of -1 and then heading slowly back up to 0. So this is going to be this up, back to the middle, down, back up to the middle function that we graphed on the last page, but with these very specific values that are hitting a maximum of 1 and a minimum of -1. So as you can see, I filled in this table for you again here, and we're just going to be graphing these points. When we're graphing these points, there are only a few that I really care about. I definitely care about all of the even ones. So the 0, the 1, the -1, and the 0. If you're graphing those points, you're going to be getting enough to make your graph look good. If you can add in the 0.5, because those are easy to graph, then we're going to be getting an even better graph or a more accurate graph. So as you can see, I've graphed the zeros, the ones, the -1s, and all of my 0.5s. When I'm connecting these points, it's super important that I'm connecting them with a smooth curve. I don't want to see a whole bunch of straight lines connecting all of these points like this, so it looks like a funny kind of pointed triangle. It needs to be as smooth as possible, and we can add arrows on the ends because we do know that this would repeat forever and ever. Thinking about the sine function, which I'm going to paste in the bottom here shortly, we're going to be answering the following questions. So this is the graph that we did on the previous page. We're going to use this graph to talk about the maximum and the minimum. So we can see that the highest this graph gets is 1, and the lowest that this graph gets is -1. So anytime we're graphing sine, that's going to be a key point. The amplitude, so remember the amplitude is from our middle line up to the maximum, or from that middle line down to the minimum. It will be the same no matter which one we look at. And so in this case, our amplitude is 1. And our sinusoidal axes, this is the middle line. Now, since this is even about this x-axis, our sinusoidal axis is at y equals 0. So it's happening right on the x-axis, right when all of these y values are 0. And then period is how long it takes to do one full cycle, which in this case I can see is 360 degrees. Now the domain and range of this function, we have done this for sinusoidal functions before, so the domain is just xer. This function will continue on forever and ever in both directions. The range is a little bit different, so the range is yer for sure, but there are some restrictions. The lowest that it would ever get is -1, and we already said that the highest it would ever get is +1. So we are able to fill in our range like this. We are going to be able to get y values anywhere from -1 to +1. The last thing that we have to do is mark the 5 key points associated with sine x. So these are the 5 that I've highlighted in green right here. I said that those are the most important ones. The 0, 0, which is where it starts. The 91, which is my maximum. The 180, 0, which is right back down here to this sinusoidal axis again. And then the 270, -1, this is my minimum. And then the 360, 0, this is the ending of my first period. At this time, I want you to go and attempt to do the sine function assignment. If you have any questions, please let me know in the chat. I would love to help you.